Hello and welcome to week 9 of cis204 Unix shell scripting and utilities, and this is part 1. So let's get rid of this cheesy camera and we'll jump right into the streamlined editor, or SED. Now, the fun thing is SED basically comes to us from long ago, if you want to consider the 1970s long ago. Some of you do, but I don't particularly. And uh, basically, it follows along the notion of grep in the sense that it will get or globally search for a regular expression and then print the result to standard output. But it does it a little bit differently. In this sense, ed is the tool that this thing came from. And rather than go into the editor, SED was a way of editing without having to go to the line at a time editor. So, without further ado, let's jump into Streamlined. And what you see in front of you is the Commodore Vanderbilt, which is a streamlined train. Yeah, SED's about that old. So, it's a streamlined, non-interactive editor. It allows editing commands to be entered on the command line, not via an editing application like ed or vi. It is also, and this is important to understand, it is non-destructive. The file that you run SED on is not updated by SED. SED takes a line at a time from a file, transforms the regular expressions to whatever you want them to be, and sends the output to standard out. Now, of course, we remember redirection, and you can redirect standard out to another file. Linux uses GNU SED, but again, the SED implementation will vary from distribution to distribution, and there are some differences, and we'll take a peek at some of the differences between CentOS and Ubuntu if they still exist. So how SED works. SED will process a file one line at a time. The current line is stored in a buffer known as pattern space, and then the output is returned to standard out. In other words, it reads a line of text, and remember the line of text ends with a $sign in the Unix environment. It reads a line of text, it makes the replacements that are requested. It then sends the updated line of text to standard output. It uses the buffer for the current line of the file. The file itself remains untouched. It's the line in the buffer that's updated. So it has a buffer. It updates the line in the buffer. It outputs the buffer to standard out. Regular expressions are used in SED. The delimiter can be user specified. It can be, it can be almost anything. But the default delimiter is slash. To change the delimiter, you'd use a / in the new delimiter character. So here in the examples, it's SED space -n or quiet. I need a /, which is my delimiter, find 12, and then because the / is a delimiter and I'm using it in a date expression, I need to escape the / so that SED doesn't try to interpret that / as a delimiter. And then I need to escape the / again after the 10 in order to see the 04. And then the standard delimiter, which is a / and print. However, if you wanted to use X as a delimiter, you'd do a SED space -n, open quote, escape X. X is now marked as the delimiter, 12/10/04, a date as you'd expect it. X is the closing delimiter, P to print everything, and then the close quote, some file. So what's the N option? It's the no print or quiet option. It does not print lines of buffer to standard out. It just is quiet. How do I restrict lines? Normally, it would take every line in the file in. Sed would look for every line in the file, but you can tell it not to read certain lines or to get rid of certain lines before taking other actions. So restricting lines is known as addressing. Normally, sed will process all the lines in the files, as I've said previously. So restrictions can be line number, a range of lines, two numbers separated by a comma is the range, the end of the line, or by a regular expression or combinations of the above. All right, and I said end of line, but the $sign not only represents the end of line in Unix, but it can also represent the end of file. So a 1 comma $, will read all of the lines in the file, 1 through the last line. A 1 comma 3D in this example that is shown here will delete the first 3 lines of the file. Now, what do I mean by delete the first 3 lines of the file? It doesn't mean that 3 lines will be deleted in the file, but the first 3 lines will not be shown by sed. In other words, they won't be output to the buffer. They won't be shown to standard out. So basically, the 1 comma 3D tells sed, ignore the first line, ignore the second line, ignore the third line. Don't do anything with them. Don't send them to standard out. But on the 4th line, start doing some work. There are at least 15 functional commands available to sed, from printing lines, which is P, which we've seen before, to substituting text strings, S, to copying contents to a buffer, H for hold. There are at least 5 substitution flags. Globally substitute is a G. In other words, everything that matches that in a line, substitute. That'll exchange you can exchange the contents of a holding buffer, X, or you can write lines to a file, W. Sed also has some options, from allowing multiple edits, -E. In other words, do this edit on the line, then do this edit on the line, and then output it here. And suppressing default output, the -N for no print. So how do you modify a file? So you're reading a file, sed's moving on that or working on that file a line at a time. You need to put that file somewhere. So you redirect the output, standard out, to another file. And then if you want to overwrite the existing file, then you would move the new file into the old file. But you don't want to do that without thinking it through. It's more often appropriate to write the output to a new file and leave the old file intact. It can be removed at the user's discretion, or if it was created in the previous step, it can be deleted. But you want to use caution when you use sed and then try to, or go through and try to overwrite the existing file. Sometimes you want to leave the existing file intact. So, how does GNU sed work? Well, we can issue sed with the -H option, and it'll describe the currently available options used for sed. So let me do this. Let's try a sed -H and see what happens. So we get quite a bit here. Sed invalid option. Isn't that special? But let's try the sed dash version and see what that does. Here we get license GPL v3 plus, GNU GPL version for 3 or later. This is free software. You can change and redistribute it. This sed was written by Finlayson, Lord, Pizzini, and Bonzini. So just out of curiosity, let's take a peek and see what it is in -- version, right? This should work, right? Here it is. This is sed 4.2.2. This is sed 4.2.2. So currently, the CentOS image and the Ubuntu 15.10 image are using the same sed. At some point, they were different in the recent past, but they no longer are. So that's a good thing. So how does sed work? Well, sed looks for a particular string of text and then it moves on. Let's see what files we have in here. We've got this, let me do a more on Audi 1 for grins. So it's the regular Audi duty.txt. So let's do this. Sed. Let's substitute GM or Audi, find Audi and substitute GM for Audi and do it globally. And we'll do that on Audi underbar 1. And we'll pipe that to more because it's going to find it more than once. So, what did it do? That basically shows us that it found Audi, replaced it with GM, found it again, replaced it with GM. So it found it twice on one line. On the next line it didn't find it. On the line after that it did. You can see where it found it twice in that line. The new from GM will be rolled out. So that's one way of doing that. Now, let's do something even more fun. Let's find that. And let's see if we can. This PHEV, find that. Let's just look for pH and see what we can find here. Question mark, question mark. And we're going to substitute that for, we're going to substitute lev anytime we see a pH something or other. So let's see if we can find this. So whatever it is that we did, it did not take that and replace it. So let's see if we can fix that. Did it find it? Yep. The question mark isn't a valid metacharacter. The dot is the valid metacharacter in the match one or more. Remember, on the command line, I can use a question mark to match a single character. Sed's a bit different. Again, it plays back to the notion that each one of these tools were written by different people, so subsequently, the metacharacters may at times be the same, but not necessarily. So that's something you have to keep in mind when you're using these tools. There is a table, 5.3, on page 132 of Unix shells by example that shows us what the metacharacters are. The caret and the $sign are the usual suspects. In other words, the caret is the beginning of the line and the $sign is the end of the line. A dot and a splat match one or more characters. Dot match one, splat matches more than one. The square brackets, the square caret bracket matches or not a character in a set. Escaping parentheses will save match characters, and this we'll see later. An ampersand will save the search string. S and find that, put a dash dash and an ampersand dash dash. That will create this dash dash and dash dash. For instance, if we find, let's go back to that sed, and we'll do this. Substitute PHEV in a dash dash P ampersand dash dash. We'll do that globally, and we'll do that on Audi underbar 1. And let's take a look at what happens. So somewhere in here, we should have the PHEV, and there it is. So that took PHEV and surrounded it with 2 dashes on either side and placed all of that inside the existing brackets. Here it is again. So that's interesting. The word boundaries, the escape, less than, escape greater than, are the beginning and end of the word anchors. And then you can do repetition of a character. X, escape the curly brace, how many characters you want. We've seen this before in the projects. So we know how that works. Okay. Now let's get out of this, clean this up a bit. Okay, next. So there's a data file in the chapter 05 directory. So let me do this. We're going to go to exe, Quigley, and a splat05. There it is, and there's the data file. So we're going to run more or less on the data file to see the size. So let's do a more on data file. There it is. Not much there. Let's do a word count -L on data file. Even better. There's 9 lines. So we're going to run this command. Yep. Copy that. And see what the output is. So anytime it finds north, it's going to print that line. So how many lines should I see? I suspect, given what I've got in front of me, I should see 3 lines. Remember, it's not looking for north globally. It only has to see it one time in the line before it'll print it. Well, what did that do? How many lines is that? Well, let's do this. Word count -L. What happened there? That's 12 lines. Remember that fun little -N? There they are, the 3 lines that it matches. What happened is this. Every time it matched north, it printed the line. And then it went ahead and printed the line again. It continued to output the file. It continued to send the file to standard out. So northwest, found northwest, printed it again. Found western, found southwest, found southern, found southeast, found eastern, found northeast, printed it. Then it printed it again because it was going through that file anyhow. Found north and printed it. Then it found, then north printed and then central printed. So now you know why we use the -N. Cool. So the P will print the contents of the pattern buffer, and you see that it prints the line it processes in all of the lines of the file. It's default printing. The -N option before the regular expression suppresses the prints of the line in the file that are not matches. In other words, it didn't match the north anywhere in that southeast line. But it's going to print it anyhow if you don't tell it not to print it. So there we are. And I think at this point we're going to come right back here in a moment, and we'll continue with part 2 of chapter week 9, Streamline Editor. This is cis204, Unix shell scripting and utilities.